Good. Okay, I'm recording now. All right, so here what we're doing is we're starting in chapter 2. We're in the second section. Okay. I also did post more questions, practice questions, that is, from the text. Oh, wait, I didn't post that yet. I'll post it today then. Okay. All right. Okay, so here we're in 2.2. Basically, here we're looking at graphs of equations in two variables. You know, before we saw equations in just one variable, right? You know, we saw like 2x plus 3 equals 5, I don't know, something like that. But now we're going to kick it up a notch, so to say, and we're going to look at equations in two variables. We're going to basically add y in there, so to say. In particular, we're going to see a certain graph called the parabola, and you'll see that has to do with quadratic equations, you know, polynomials, that is, of degree 2, and we'll see the circle as well. Circle is actually very important, especially when we do, especially if you go on to pre-calc and do trigonometry. So, all right, so that's what we're going to see here, okay? So you probably have seen graphs before. You might have even sketched graphs maybe in high school. I mean, I'm not too sure. Excuse me. But what exactly is a graph, though? Well, a graph is nothing more than just a collection of points plotted in the Cartesian plane. Cartesian plane is also called the XY plane. But a graph is nothing more than just a collection of plotted points in the plane. So here we just have the point 1, 3, right? I mean, that's technically a graph. I mean, it may not be a graph you're going to spend hours studying or something like that, but it is technically a graph. Well, that's what it is by definition. So that's some terminology. That's what a graph is. As you can see, math does have a lot of vocabulary in it. And here's some more terminology. Remember how equations in one variable can have solutions, right? You know, we've seen that before. And those solutions are just numbers you could replace the variable by that make the equation true. Well, for equations now in two variables, x and y, since there are two variables here, there are essentially two numbers you could plug in, right? So here, a solution is going to be an ordered pair. So in other words, a solution to an equation in x and y, it's an ordered pair of numbers, a, b. The first number you can substitute, okay, in for x. The second number you could substitute in for y. And when you do that, the equation is a true statement. That's just what a solution, for an ordered, that's what a solution for an equation in two variables is. Again, it's an ordered pair. The first number, the x coordinate, right? You plug it in for x. The second number, the y coordinate, you plug into y. And when you do that, the equation is a true statement. For example, let's look at this equation. Although you probably know, well, let me not go there. Here, is this the solution, this ordered pair 2, 3? Well, it turns out it is. Now, why? Well, if I replace x by 2, y by 3, what do we get? 3 equals 2 times 2 minus 1, right? Well, as far as I know, that's a true statement. That's just saying 3 is equal to itself. So this is a true statement. So this is a solution. Now, is that the only solution? Well, you probably know that, no, it's not the only solution, but that we'll get to later. What about 1, 3? Is that a solution? Well, the answer is no. Now, why is that? Well, if I replace x by 1 and y by 3, right, we get this. Well, what is this saying? This is saying 3 is equal to 1, which is not true. So because it's not true, that tells us this is not a solution. Okay, remember, equations can be true or false. Okay, so this is a false statement. What about the origin, right, which is 0, 0? Well, that's not a solution either, right? Again, if you replace x and y by 0, you end up getting 0 equals -1, which is definitely not true. So this is not a solution either. Okay, so we know what solutions are. In fact, we can actually obtain many different solutions. Essentially, you could just let this x here vary, and for each x, you calculate a corresponding y, right? From that, you can obtain many different solutions. You know, if I let x, for instance, be 1, I would get y would also have to be 1. And so 1, 1 would have to be a solution. If I let x be 0, what I would actually get for y would be -1. So 0, -1 would be another solution. So you can get many different solutions that way. And in fact, taking it a step further with graphs, the graph of an equation, not just this one, but if you have an equation in 2 variables, x and y, the graph of it is the plot of all its solutions. It's the plot of all its solutions. So 2, 3 would be on the graph of this equation. These 2 points, however, no, they wouldn't be. But again, the graph of the equation, you're plotting all these solutions to it. Good. All right. So that's what the graph of an equation is, okay? Although you probably know that this graph is a line, but that comes later. Here's an example. This is actually what I meant by here, letting x vary and calculate corresponding y. We could do that to get many different solutions. For instance, if we let x be -1, right, we can calculate y. We get y is 2 times -1 minus 1, which is -3. So since when x is -1, y, we calculate it to be -3. We get the ordered pair -1, -3. This is what we get. So this is a solution, right? We got when x is -1, this calculation shows y has to be -3. So this is a solution. When x is 0, as I said before, we can calculate y to be 2 times 0 minus 1, which is -1. So 0 minus 1 is also a solution. When x is 1, 2 times 1 minus 1, right? We actually do get 1 again. So 1, 1 is also a solution. And you can keep on doing this. I mean, there's infinitely many solutions you can get. If you were to plot all of them, you would get the graph of this equation, which turns out to be a line. I mean, I did plot 2 points here. So I actually graphed this using GeoGebra, which is free software you can use. So we have that. The next graph here, I actually just made the graph a little bit bigger. I put the title in there. But again, this is the graph of y equals 2x minus 1. So every solution to this equation is on this line. All those points plotted together give you this line. You know, here's 1, 1. You can see that. This is 0, -1. Okay? And so on. Someone have a question? Okay. Oh, so someone asked a good question. Let me just read it. That mic isn't working. I'm not sure if you mentioned it, but for the x column, the numbers chosen, just the numbers in between the numbers in the equation. Those numbers I kind of chose randomly. -1, 0, 1. I just chose those randomly. I could have chosen any numbers I want. So if I were to ask you to graph something like this on an exam, those X values I would actually give you. Exactly. I would either choose the numbers for you, like on an exam or something, or theoretically, you could choose any numbers here you want. I mean, I could have chosen -10, 0. I could have chosen 1,000,000,000. Why would I do that? I don't know, but you could choose any numbers you want. Okay, you're welcome. Good question. Okay, but again, these X values, I did skip that, so I'm glad someone asked this. These X values here, I chose those kind of randomly. What am I doing? Oh boy, sorry, wrong button. There we go. But these numbers here I chose randomly. You know, I could have chosen -2, -1, 0, or whatever. So I just chose these at a convenience. So, okay. Okay, so I'm glad someone asked that. Any other questions though? But again, if you were to graph all of these points, all the solutions, you would get this line. I mean, you can see another solution when x is 2, y is 3. That's a solution we saw already, right? That's on the line. Good. All right. Here's 0, -1. So, all right.